When we look up at the stars and see those bright stars shining in the night, we often have the illusion that these celestial bodies are suspended in space. However, this is only a visual illusion. In fact, the celestial bodies are moving in their orbits at high speed all the time. The truth behind this phenomenon involves a fundamental understanding of force and motion in physics. In ancient times, people lacked an in-depth understanding of the laws of physics, and often had some wrong ideas. For example, the ancient Greek philosopher Aristotle believed that force is what keeps objects in motion. This view was widely accepted at the time and dominated the academic community for a millennium. According to this theory, it seems that celestial bodies also need some kind of sustained force to maintain their suspension. However, with the development of science, this misconception was eventually corrected by Newtonian mechanics. Newton's first law states that force is the cause of changing the state of motion of an object, and if the net force on an object is zero, then it will either remain in a uniform linear motion or remain at rest. The stable movement of celestial bodies in space is not supported by some mysterious force, but because the forces they are subjected to reach a delicate balance. In the case of the Earth, it is not only subject to the strong gravitational pull of the Sun, but also by other celestial bodies such as the Moon. The direction of these forces is not perpendicular downwards, but towards their respective sources of gravity. In the case of the Earth, although we do not feel it, it actually moves around the Sun in an elliptical orbit under the combined action of the Sun's gravity and the centrifugal force generated by its rotation. If the Earth is compared to a satellite orbiting the Sun, then the initial velocity and gravitational pull required by it constitute the conditions for its motion around the Sun. In the same way, the gravitational pull between celestial bodies is also a key factor in their ability to orbit each other in space without falling. If we look at it from the point of view of Newtonian mechanics, we will find that the celestial body does not have a downward force to pull it, so it does not fall. On the contrary, celestial bodies move along their own orbits because their net force in space is zero, which is the real reason why they are stably suspended in space. With the further development of physics, especially Einstein's general theory of relativity, we have a deeper understanding of why celestial bodies do not fall. General relativity subverts the notion of gravity in traditional Newtonian mechanics by arguing that gravity is not a real force, but is caused by the curvature of spacetime by the mass of an object. According to the general theory of relativity, when a celestial body such as the Earth exists in spacetime, its mass bends the surrounding spacetime, while other celestial bodies move along geodesic lines in this curved spacetime. Geodesics are the shortest path in high-dimensional spacetime, and from our three-dimensional perspective, celestial bodies appear to be moving along an elliptical orbit, but in reality, they are traveling along the most direct path in four-dimensional spacetime. This is further illustrated by Einstein's equivalence principle, which states that there is an equivalence between a frame of reference for a properly accelerated motion and a gravitational field. This means that the gravitational force we feel on Earth can actually be seen as being caused by the curvature caused by the Earth in spacetime. From this point of view, celestial bodies are not suspended in space, but are supported by spacetime itself, and it is the structure of spacetime that determines the trajectory of celestial bodies. Summarizing the above analysis, we can understand that celestial bodies can neither levitate nor fall in space, and their motion is completely determined by the net force to which they are subjected. In the absence of an external force or zero resultant force, the celestial body will remain in a uniform linear motion or at rest. The gravitational effect between celestial bodies, as well as the velocity of the celestial bodies themselves, determines their complex and orderly trajectory in space. Specifically, celestial bodies such as the Earth do not fall because they have zero net force in space. For example, the gravitational pull of the Earth and the centrifugal force generated by its rotation are perfectly balanced in magnitude and direction to allow the Earth to move steadily in its orbit around the Sun. Within the framework of general relativity, this motion can also be understood as the Earth's geodesic motion along spacetime around the Sun. Thus, whether according to Newtonian mechanics or general relativity, the motion of celestial bodies can be interpreted as a natural result of the action of their respective gravitational fields and initial velocities. Celestial bodies do not levitate for no reason, nor do they fall for no reason, and each of their states of motion has a definite physical cause.